All right, so we are looking at section 7.2, called anti-differentiation by substitution, usually called U-Substition, shortened to U-Sub. So when you hear me reference that, this is what we are talking about. We start off, on the right side is a list of all the integrals that you guys should already know. So it's a nice little concise table to help you study it. There are some that you do not know. Okay? All right. In our first integral, we're just evaluating an indefinite integral. This we know how to do. Evaluate the integral of x squared minus sine x dx. What do we get? X. Nothing new here. X. Cubed. Thank you. 3. And what did you start with to get negative sine x? Plus cosine x. Then? Plus c. It's our reminder, indefinite integrals have plus c. All right. Now, before we get into U-Substitution, something you need to pay attention to when you're doing integrals or when you're asked to do an integral is our variable must match our differential to be able to do the integration. Okay, so in this problem, they said, let f of x equal x cubed plus 1. Let u equal x squared and find each of the following antiderivatives underlined in terms of x. So that means in the end, my answer better have x's in it. Okay, so we're going to start off with a, which is the integral of f of x dx. And let's plug in what that is. That is the integral of what? X cubed plus 1. Yeah. And this one we can easily do. It becomes x to be what? 4 over 4 plus all right, now the next one says, let's do the integral of f of u du. That means we're all in u. Well, what is f of u? F of u is just plugging u into f of x. So it would be the integral of u, so it's just plugging u in, the letter u for x. U cubed plus 1.
Even though u is x squared, then
Yeah, not yet, because we are doing u and du, so we want to stay completely in u. So how would you do f of 3? 3 cubed plus 1, right? Yeah. So don't make it difficult. It's just f of u, we're plugging in u instead of x. In the end, we'll come back to our x's. But for the integration, they want us to do it in u and du.
okay.
All right? So here we get what? U to the 4th over 4 plus u.
Oh, and then this other.
There you go. Plus c. But our answer should be in terms of x. So now we replace u with x squared. So we get x squared to the 4th over 4 plus x squared plus c. So if it is free response, any form of the correct answer is correct. If it's multiple choice, they will never go to you. So you should recognize that we should be willing to write that as x over 4 plus x squared plus c. Okay? All right, now they mix everything up. Now they want the integral of f of u dx. So let's write that in first. So we get the integral of f of u dx equals the integral of u cubed plus 1 dx. But can I integrate it when it's in that form right now? Nope, I have u's and So, before I can integrate, this is the case where I'll have to do what? Substitution. Our u is what? X squared cubed plus 1. Yes. And that is x to the 6, so when we integrate that, we get x to the, careful, x to the 7. Once we integrate x to the 7 over 7 plus x plus b. So each of these giving us a different solution. We just need to be very careful about how we are plugging into our integration. Yes? Questions on A, B, or C? All right. Okay. So now, the new stuff. Now we had a problem similar to this one on the homework where we had to just look at it and say in our head, what did I start with to get this as my derivative? Well, now we'll learn a process. The process is called U-Substitution. It's used most often when a chain rule has been applied in the derivative. Okay, so when we have composition of functions. And what we want to do is rewrite this integral to no longer be in terms of x, but to be in terms of another variable, u and du, such that it's an easier integral to solve. And just like we just did, we'll go back to x's in the end. Okay, so we replace things with u, do the integration, come back and replace the x. When you are choosing your u, I always say that you want to pick the part of the function that's having the most done to it, or another way to think about it is what's most inside. So, what's having the most done to it, what's most inside, is this cosine x. So we're going to let u equal cosine x. Now remember, what we are looking for, we want to get an integral of a function in terms of u with a du. That's what we want it to look like in the end. Well, I now know that I have u equals cosine x, so I'll have an e to the u. So that'll account for this. But I still have sine x and dx change into u and du. Well, how can I get to du from u? How can I get to du dx from u? Take the derivative. So du dx equals what? Beta sine x? Alright, well you can see we have a sine x up here that we want to replace, but we also have a dx that we want to replace. So we're going to multiply this dx up over here. So we have du equals negative sine x dx. Now, from now on, you can skip this interim step. You don't have to write du dx. You can always write du equals something times dx. Okay? All right, but I don't have a negative in my original, correct? Like I can now, du will replace sine x and dx, but I don't have a negative up here. So I want to match exactly what I have up here. So I'm going to divide this negative over to the other side of du. So negative du is the same as sine x dx. Yes, that's what we did to get this time. All right, so now I can replace e to the cosine x with e to the u, and I can replace sine x dx with negative du. All your constants, when we pull them, we'll move all the way out in front of your integral. So we'll have the negative integral of the sine x dx is replaced with negative du, so I'll let my du out here. And then e to the cosine x is replaced with e to the u. So this is the easy integral that we do now. Question here?
Yeah, so I'm just, I guess you're not getting why taking the derivative, let's replace it.
All right, so taking the derivative of u with respect to x gives us the u dx, correct? equals negative sin x. These are differentials. We can just treat it like division when we have it in an equation to move it over. So we end up, when we move things around, that negative du is exactly the same as sin x dx. Okay? They are exactly the same. It's another way of saying the same thing. So instead of writing sin x dx, I'm writing negative du. Okay?
So
And
you're doing it so you can put it in terms of the...
Right. Right. And a very easy integral to take.
Yeah.
Okay? We've simplified this. So now when we take our antiderivative, we get negative what? Negative e to the u plus c. And now we can just go back to x. What is u? Negative e to the cosine x plus c. But a constant can be negative. We can rename any constant with c, so I could make that plus negative, right? So we just consistently call it plus c. Okay. All right, other questions here.
So that negative came from the one that was...
This
from the
negative here
u.
came from the negative d. Yes. Not from the integration at all, just from the negative d that we have right here.
So that's just the, like the formula or whatever to the derivative of,
It is. It is. So this one's kind of easy to see, where we wouldn't have really needed U-Substitution. But I promise there are many where we need U-Substitution to see what's going on. All right, so let's try another one. What time am I out of this class?
25.
Okay. All right. So, when you pick a U, if you pick something and it's not working, stop and go pick something else. Okay, you'll get very good at determining what U is, but in the beginning, when you pick something, if you're in the middle of the integral and you're like, I don't know what's going on, start over, pick a different U. And when you pick your U, do not separate terms. Keep terms together, things that are added and subtracted. Do not separate terms when choosing U, generally speaking. You'll find that nothing is always in calculus, so I have to condition my statement, but generally speaking, like the furthest inside of this is 5 plus 2x cubed, don't separate the 5 and the 2x cubed. All right, so the most inside, 5 plus 2x cubed, so that's our U. That's the U that we're going to try. If it doesn't work, we'll try something else. So U is 5 plus 2x cubed. Du, which we just take the derivative, is what? X squared dx. Okay? And again, we're skipping the step where we write du dx and then we multiply by dx. All right, well, how are we doing? I see the square root of u, which is something I know how to take the integral of. I see an x squared dx, but down here I have a 6x squared dx. What do I need to do? Move that 6, divide it over. So 1/6 du equals exactly x squared dx. Now can I replace everything that I have in x's with u? Yeah. I'm going to replace this with u, so I'll have the square root of u, and I'm going to replace x squared dx with 1/6 du. So let's rewrite.
Are you going to put the front of 6 in front of the...
I am, in front of the integral. I'll always pull that constant up. 1/6 the integral of square root of u du.
I don't know what the purpose of doing that is.
Which part?
One not from the intro.
Well, if you were integrating 2x squared, what you're really doing is x cubed over 3 times 2, right? I'm just pulling that 2 out of the way. Because a constant times a function, the constant can come out in front of the integral. That's all. All right. Well, let's go ahead and integrate. We've got 1/6. Let's remember that's the integral of x to the 1/2. Not x. Don't want to do that. U to the 1/2. Du. So I'll end up with 1/6 times what? U to the what? 3/2 times 2/3. Over 3/2 or times 2/3. Plus b. We were doing an integral in terms of x to begin with, so we need to go back to x to finish. So that is 1/9. What's the 3/2?
5 plus 2.
Good. 5 plus 2x cubed. So 3/2 plus. Are we good? Yeah, so you get it now? So u to the 1/2, when we integrate that, we get u to the 3/2 over 3/2. So when we divide by 3/2. All right, questions on that one? Let's do more. This is all you're doing tonight, is a bunch of these. Okay? All right.
Are we on page 7?
We're on better page. I didn't get to this one. All right. Yes, this is a good one too. So here's your helpful news. If you are integrating a trig function of something other than just x, you need to do so. If you are integrating, let me say it again, a trig function of something other than just x, so this one instead of x, you need to do so. Okay? If you are integrating e to the power of something other than just x, you need to do so. So, integral of trig of a function of x and integral of e to the power of some function of x other than just x, use them. Because people always forget that little extra concept. All right, first off, how is the integral of cotangent? That's the derivative. Yeah. Do we know the integral of cotangent? No, we do not. Back in trig, when you were doing identities, what was the first thing you did?
Negative 1 over 1.
That's inverse tangent, not cotangent. Good idea, thinking about 1 over tan, but when we go back to identities and trig, sines and cosines are the most helpful. So rewrite this in terms of sines and cosines. This is the integral of what over what? Cosine 7x over sine of 7x dx. All right. So now, here's another type of problem. With a fraction, quite often you're u is in the bottom. Because you could be the top or the bottom this time when we cover the other one, right? When we did our derivative. If I chose cosine 7x to be my u, then wouldn't the derivative be sine? But then we get a little crazy because we get a du in the denominator, which we do not want. So when you have a fraction, the first thing to try is the denominator. But we're going to do a double layer here. What is x is tricky? Let's first get rid of the 7x with u. Okay, so let's let, this one is, let's let u equal 7x. So now what I have is the integral of cosine u over sine u. So let's get our du will equal what? 7 dx. All right. And we don't want that 7, so we'll have 1/7 du equals dx. So now we'll have 1/7 cosine u over sine u du. So that was quick. All right. That's what we need to do now. Another U-Substitution. Let's call it a P-Substitution, because we can't integrate that either. So it's the second layer. So we are going to let P equal, now what did I say when we have fraction? Which one do I choose, the top or bottom? Bottom. Sine of u. So dt would be cosine u du. A little tricky, there's a double layer here. All right, but look how nice that is. That's everything I need, isn't it? Sine u I can replace with p, and cosine u du I can replace with dt. So what do I have for my integral now? 1/7, the integral of dt over b. All right. Another way to write that is 1/7 the integral of 1 over p dt. That's the same thing, right? And we know how to integrate 1 over p. So, okay. All right. So here we get equals 1/7 the natural log. Ooh. There it is. Of the absolute value of p plus p. All right, and what is p? So 1/7 natural log the absolute value of sine of u plus p. But our original was in terms of x. So it is 1/7 the natural log the absolute value of sine of 7x plus b. Dot in there. Nope, that's true. That's true. Okay? But what we did just do is derive the integral of cotangent. So the integral of cotangent of x is the natural log of the absolute value of sine of x. So, again, both differences. The integral of 1 over x should be the natural log of the absolute value. I'm not sure if this book always puts in the absolute value. Should be. All right. So, let's try one more. Getting so far. See if it's this one that I want to use. Although if this is in your book, you should take a look at it. Kind of a nice practice on trig. But I want to get to a definite integral if I can. There we go. We'll start with this. We'll start with example 9. All right. So, now we have a definite interval. And again, it's a little bit of tracking that we have to do. There's two different ways we could do it. We could stay in u to the end, and then plug back in and do our subtraction in x. And that's what we'll do first. All right? So, what do you think your u will be in this case? Ignore the upper and lower limits until the very end. So treat it like an indefinite. What's my u? Yeah. X squared minus 4. And du is 2x dx. All right, do I have a 2x up here? Nope. So what should I do? Divide by 2. So 1/2 du equals x dx. I can now rewrite it. 1/2 out in front. Integral of what? over, that's pretty good for you, didn't you? Right? Yeah, the 1/2. We're not gonna think about that till the end. Okay, so that is the same as 1/2 the integral of 1 over u du, which is 1/2 what? The natural log of the absolute value of u. We don't have to worry about the plus b this time because we have limits that we're going to plug back in. All right, and that's 1/2 the natural log of the absolute value of what? What is u? X squared minus 4. So now, no plus b, so now we're going to evaluate it between 0 and 1 because it's a definition of it. So we'll have 1/2 the natural log of the absolute value of 1 minus 4 minus 1/2 the natural log of the absolute value of 0 minus 4. No plus b because it is definition. All right, homework is on the assignment sheet and your script from the headlines due Monday morning, first thing. I will be here early Monday, that's 6:45. We got to, you're still in the book, okay? You'll see in the book, if you look, another way that we can do this, we have an integral, but we'll talk about that on Monday. Have a good weekend.